In this example, I want to show how to add and subtract radicals, but we're using a cube root example. As you notice here, we've got an index of 3. And you'll notice that we're not starting with like radicals. So the little note up here, I just want to have a look. When you're adding and subtracting radicals, it helps to express each one in simplest form first. So we're going to simplify first, and then we can look to see if we have add and subtract, or like radicals to add and subtract. So let's just do our simplifying first. I've got my list of perfect cube numbers right here. So I'm going to use the method of simplifying using the highest perfect cube. So when I look through my list, the number 64 I know divides into 128. So I'm going to rewrite that as the cube root of 64 times 2. Now, 64 is a perfect cube number. So the cube root of 64 is 4. If you need to use your calculator to find the cube root of 64, that's fine. You could use that. So I'm going to rewrite this as 4 cube root 2. Now 16 is a much smaller number. When I look up here in this list, I notice that 8 is going to be the only number that divides into 16. So I'm going to rewrite this as the cube root of 8 times 2. And I know that the cube root of 8 is the number 2. So I'm going to rewrite this as 2 cube root 2. Now, these expressions which I have here, I need to transfer those back now to the original example. So back here, I'm going to rewrite this as the number we just found. So we said that this was equal to 4 cube root 2. And we said that the cube root of 16 was equal to 2 cube root 2. As you notice, we now have like radicals. Their radicands are the same. Their index is both 3. So these are considered like radicals, and now they can be added. So 4 plus 2 is 6, and I would keep my index of 3 and my radicand of 2 the same.